Let's start today's lecture, and today is the day one of Cisco ICE. Okay, so we're going to talk about the ICE. ICE full form is Identity Service Engine. Identity Service Engine. This is basically the full form of the ICE that we should know as of now. And let's start from the basic. What is an identity? So according to the Oxford Dictionary, an identity is nothing but serving to establish who the holder, owner, or the viewer is by bearing their names or often other details such as their signature or a photograph. Someone who could walk up to you and say that his name is Nitish, but how would you know that identity is true? You or we need to provide some type of trusted evidence such as a third-party form of identification, say a driver's license or passport, to verify his or her credentials. In a very similar way, in the world of the networking, an identity can be a username password for a user, or it could be a MAC address of that particular end-host device. So what is an identity? An identity is nothing but, like for human beings, the name is an identity. The fingerprints could be an identity for the biometric entrance. Okay, blood group, and so forth. Many other things are there which can define that you are XYZ person. After that, so an identity could be a username, or it could be a fingerprint or blood group or any XYZ thing of a human being. In a very similar way, what could be an identity in the world of the networking? What could be? So you could have a laptop or an iPad or a mobile phone. Those particular devices which is being present over there will get a username, and simultaneously you will get a password for the same password, username and the password. You will get both the things. Okay, so a username along with the password could be an identity of an end user. There are certain, and what could be the end host device, the identity for which device we are talking about, the end host devices, like laptop, like it could be a laptop, it could be what? Desktop, it could be phone. I'm talking about mobile phone. It could be an IP phone also, Cisco's IP phone. It could be an access point. It could be a printer, fax machine, IP camera, and nowadays there is a concept of an IoT, right? So you can get a MAC address to your lights also, refrigerators, your washing machine, everything is getting connected. So those devices also, whenever they are trying to come into the network, right, they want to get authenticated and their identity will be the MAC address. There are certain devices who does not consume the username and password, like fax machine, like printers, like your IP camera, right? At that particular moment, what is the identity of this particular device which will be used to authenticate them against the AAA server, which we'll see in a few minutes? That is nothing but the MAC address. So coming back to the slide, what is an identity? So in the world of the networking, an identity could be a username, password, or it could be a MAC address of that particular end host device. Next, what is an identity store? A database can be used to authenticate a user's or an endpoint's credential, internal or external. Each individual identity store is referred to as identity source. You can combine multiple identity sources into an identity source sequence that can then be processed for user and endpoint authentications and authorizations. Let's understand that, what I'm talking about. I have an ICE, Identity Service Engine. ICE has a database, and name of the database of ICE is called as SAMDB. What do you call that? SAMDB. The name of the database for ICE is called as SAMDB. So ICE database name is called as SAMDB. SAM is the name of the database for the ICE. That means in the world of the ICE, you need to add the identity. Now you know that what is an identity. You're going to add the MAC address of, let's say, for example, printer. You're going to add the MAC address of your fax machine. You're going to add a user. Let's say, for example, Nitij, you're going to add a user called as Bob, and so forth. So what is going to happen is this ICE has a database. Name of the database is SAMDB. That database is called as identity source. Remember that. Identity source means there are multiple groups also available, like endpoints. So all the endpoints will be added with their MAC addresses. All the users will be added with their username. Along with that, there could be a guest users over there, right? Like contract basis, weekly basis, permanent employees in the company, right? There could be guests like that, or these all are being stored. These all are being stored where? In the database of the ICE. ICE has its own database. Saying this, whenever you store the identity of a particular XYZ endpoint, that identity, if you are storing in the ICE database, that is called as internal database. In a very similar way, you can integrate ICE with an external database also, like it can get connected to the Active Directory. It can get connected with the LDAP servers. It can get connected with what? Your other devices, radius servers, open standard radius server, Kubernetes, many other stuffs are there. Many other external identities are also there. So this is what I'm trying to explain you. A database can be used to authenticate a user's or an endpoint credential. A database, identity store database, could be internal, which is nothing but we are talking about the SAM database, or it could be external. It could be an ICE integration with Active Directory, ICE integration with the LDAP server, and so on and so forth. Each individual identity store is referred as identity source. Remember that. Identity store, where you're going to store the data, that is called as identity source. And you can combine multiple identity source in an identity source sequence. Now, what I'm trying to say that I have user endpoint, like I'll explain it over here. Try to understand in this particular slide. I have one identity source as internal endpoint, in which I'm going to add all the MAC addresses. I have one as an internal user, where I'm going to write all the username and the password. I have one identity source as guest list, Active Directory, all AD join points, whatever the rest of the join points or rest of the external databases are available over here. These are the available identity source available. And can you see over here the options of drag and drop? You can drag it from this available to selected, and you can call it back from selected to the available. So you can write it down. First, I want guest user, this particular database to be checked. If the user did not found into this, check the Active Directory. If the user did not found in this, check the internal users. If the user does not found in this, check all AD join points like this. This is called as ISS. This is called as identity source sequence. What, like an access list, if you write the ACE entries, the first ACE entry is going to be checked first, then second, then third, then fourth, then fifth, and so on and so forth. In a very similar way, ICE also check the sequence. ICE also have source sequence. That means what order? There are so many different databases are there. What order should I follow so that I'll check the user against that particular source, identity source. This is called as identity source sequence. Till now, everyone is clear? Now let me give you an overview of the ICE. Okay. Cisco Identity Service Overview. Now, what is an ICE? Let's talk about an ICE now. You know what is an identity. You know what is an identity store. Now let's talk about Cisco ICE. What is the definition of Cisco ICE? Cisco ICE is nothing but a centralized security solution that automates context-aware access to the network resources and share the contextual data along with that. This is the definition of the ICE. Okay, certain points with that. I'll explain the entire picture. ICE comes into two ways. It could be a physical device or it could be a virtual device. Okay, ICE comes in physical as well as VM, virtual machine also. Now let's understand this. Cisco ICE has a physical as well as virtual also. In your CCI lab, you are always gonna see the virtual. You will always gonna see what? The virtual ones. And in our lab practice also, we're gonna see as a virtual machine, OVA or .iso file. I have it, both are there. So these are the one which is going to be used in your CCI preparation. In the production, you will see the physical devices. I don't know whether you heard about a word called as UCS or not. This is Cisco's server. Cisco server is UCS. And in that, there are different models. I'm not going into that. UCS C series servers are there. Okay. Standalone servers are there. UCS C series. And on UCS C series server, this is UCS C series server, they have installed a CentOS operating system for the ICE. Now, ICE has different series. ICE started their journey from 33 and 3400, 3500 is there, 3600 is also there, 33 is also there. But these 3300 series, 3400 series, these are already end of life, end of sale, end of life, end of sale. These two are still in the production. You will see 3600 gradually being used into the production. This 3600 series also have different models. 3315 is there, 3355 is there, and 3395 is there. This is for your data center, big data center or ISP level, where number of users are more. This is basically for your campus, for this mid-level range, and this being used for the SOHO level, small office, home office level. Okay, so these are the nothing but different models of Cisco ICE are there. In the production, you're gonna use either of them. My bad, this is 3600. Okay, 3600. My apologies. This is 3600. 3600 have multiple variants available over here. Okay. Saying this, we're gonna talk about virtual every time. We're gonna have the virtual. It's a part of the curriculum over there. So the first thing that you should know about is over here in this particular picture, you can see here, an ICE can come into the physical or a virtual machine. Next, ICE is like a network door. The first thing that is going to hit for any end user, it is always look for an ICE or a AAA server. Now try to understand what is going to happen. I'm just going to draw a simple data center without HA, without high availability, because my diagram will not be neat and cleaner. There will be an ASA firewall at the perimeter level. You're gonna have after that the core switch. You're gonna have your distribution layer switches. You can go for your ACI leaf and spine or two-tier hierarchy also. Okay, and then you have your access layers, and then after the access layers, you have your end users. Okay, this ASA, this core switches, distribution, access layer, Obviously, all are connected to a centralized switch also, which is called as a management switch. And now with this management switch also, you're gonna connect your what? NTP servers. Generally, best practices I'm talking about DHCP server, DNS servers. It could connect your Active Directory. With this, you're gonna connect your company's syslog server, SMTP servers. With this only, you're gonna connect your ICE. So ICE is going to be checked by all the devices, because all the devices, let's assume 150.1.7.2 is the IP of ASA, 150.1.7.3 is the IP of the core, 150.1.7.4 is the distribution, 150.1.7.5 is access, so 150.1.7.6 will be ICE. All should be reachable with them. So what happens is, now tomorrow, if Bob as a user who is coming as a remote access VPN, which we have already seen that, right, in the previous lectures, RA VPN, it could be any connect with IKE V2, or it could be SSL VPN, whatever you are talking about. The moment the Bob comes with the username, I can redirect the ASA from the ASA towards the ICE, so that the Bob should get authenticated by a AAA server. And ICE is a kind of a AAA server. With respect to the ICE, the Bob should be get authenticated, and then only it should come into the into our network. In a similar way, you can have all these devices present here also. There also, when they want to get, when you just make this port no shut, they always look for what? They will also look for the ICE, because ICE is a gateway. ICE is like a network door. ICE is your AAA server, and AAA stands for what? Authentication, authorization,
Authentication, authorization, accounting.
accounting. Correct, sir. Authentication means who are you? Authorization means what you can do. And accounting means what you have done. Right? ICE is basically nothing but a AAA server. ICE authenticates the user. ICE are going to tell what he can do. And ICE is the one, whatever he is doing, going to monitor it, going to generate the logs for that. So what you have done, it is going to create the reports for the same. Everything this ICE is going to do. So ICE is basically a network door for all the end users present over there. Remember that. Now, what an ICE can do for us. So till now, you got an idea about the hardware as well as software. You got why we need an ICE. What are the features of the ICE? ICE can tell about who is connected with the basis of that username or the MAC address. ICE can tell by what application they have connected. ICE can tell when that user has connected, where it has connected, how it has connected. Means whether it is connected wireless or wired, or whether it has taken with the VPN. ICE can do the device compliance, or compliant, you can say that. Compliance in the sense, which is nothing but called as a profiling and the posturing, which I'll explain in few minutes. And all these details, whatever the ICE is going to fetch out or take out from that end user, that data is called as contextual data. That data is called as contextual data. So let me read out this definition one more time. ICE is a centralized security solution because it is centrally connected. You can see that with the management. These all are your centralized devices. DHCP, DNS, Active Directory, because they are going to connect with every device in your network. That's the reason ICE is a centralized security solution that automates context-aware access, that automatically fetch about who, what, when, where, how, and builds what? A contextual aware, automates how we automatically learns about it, but it requires certain protocol that we'll see later into a section, but it automatically builds a contextual information across the network resources, And at the end of the day, it is going to share that information also. Okay. So this is about the ICE as of now. Right side, access policies. ICE, with respect to the authorization, gives the traditional authorizations also, like you can work in this VLAN, you can work in this particular access list, and so on and so forth. And the new way of doing the segmentation, which we'll see later into the segment, which is called as Cisco TrustSec. We'll see that later into the case. Cisco TrustSec. ICE can work with the guest users. ICE can work on bring your own devices. ICE can do the role-based access, threat containment with the help of ICE pxGrid solutions. Now let's understand these are also all these particular things in few more detail. Let's assume that you have a Bob over here. Okay. Bob is connected to a switch, and that switch, access layer switch, and that access layer switch with the help of the management switch gets connected to our ICE. This switch is connected to the router. This router is connected. Now we have not talked about, but this is next generation firewall. And then it is getting connected with what? An ISP. And then after that, over the scary internet, there is, let's say for example, a server whose IP is 1.1.1.1 over here. Okay. This is simple topology, which I'm going to talk about now. What I'm trying to say here is, whenever the Bob wants to access the server, whatever he is doing, telnet, HTTP, HTTPS, whatever the protocol he is using, Bob to reach to the server, as I mentioned earlier, ICE is your network door. Okay, it is your network door. If you want to enter into the world of network, you have to first knock where? To the ICE. So the Bob will come towards the ICE first. ICE has its own database. Remember SAMDB. It is going to check that, which is an internal database. Or you could have integrated this with the Active Directory, which is an external database. If ICE gets this data into the database and it's the correct information, ICE is going to authenticate, and in return, ICE is going to tell this is what you can do. That means this is your authorization. So he has said that, Bob, you can work in VLAN number 10. Assume a hypothetical situation. Now, Bob in the VLAN number 10 will try to access what? The server one. Maybe he's doing the telnet. Maybe he's trying to do an upload certain, or maybe this is an FTP server. He's trying to upload certain things into the FTP server. He's sending a PDF file. Let's assume that. And he's sending to this, uploading it to the FTP server. Bob got an access on the basis of its identity, correct? Understand, this is very important, which I'm talking about. On the basis of an identity, Bob gets authenticated against what? The network door, which is an ICE, which is a kind of a AAA server. Now, when Bob is trying to upload the PDF via the switch, goes to the router, and then it hits what? The next generation firewall. Next generation firewall has the capability to do the inspection at layer 3. At layer 4, we haven't talked about next generation firewall. Later into the section, we're going to talk about. And then it also does DPI. What is DPI? Deep packet inspection. Deep packet inspection. What is deep packet inspection? Deep packet inspection means next generation firewall has the capability to check, to do what? Check the payload also, not only the layer 3 and layer 4 hurdles. It can check the data of the data. It can check the packet payload also, which can consist of what? Which actually can consist of the malware. So this next generation firewall has detected that whenever Bob is trying to upload a PDF towards the FTP server, it has detected it is carrying what? A malware over there. So what next generation firewall is going to do? Drop it. Bob will come to know that the packet is being dropped. Again, he is going to upload it. Again, he is going to drop it. So Bob will not come to know about that exactly why the traffic is getting dropped over there. Next generation firewall job is what? Detect it, drop it. Detect it, drop it. Detect it, drop it. That's it. But understand that There are so many different files simultaneously. The Bob, the Alice, so many different devices are there in the same segment. They simultaneously started sending the particular packets over there simultaneously towards this next generation firewall. What is going to happen? The CPU utilization of the next generation firewall has reached tremendously high. So what we need basically, we need basically an integration of what? We need an integration of this next generation firewall with this ICE. Why? The question is why. Next generation firewall will tell that boss, ICE, I have a user coming with the name called as Bob. I know because you are the AAA server in my network, you must have given him the authorization to connect in VLAN 10 towards the FTP server. I'm telling you, this Bob, whenever sending the traffic towards the FTP server, this gentleman is continuously sending the malware. Can you do something about that? ICE will say, yes, I have done the authentication for this gentleman. He is absolutely pure legitimate guy. But as you are saying that he is sending a malware, maybe that laptop got affected with that. Let me do a process called as COA, which is called as change of authorization. COA stands for what? Change of authorization. I'll change his authorization and I can isolate him. I can put him into isolated VLAN. I can chuck him out from the network so that the other devices are not going to get impacted. Okay. The connection, the integration of the next generation firewall with an ICE comes with pxGrid. This is called as pxGrid. This is basically a license. This is basically a license given by Cisco to do the integration of ICE, not only with next generation firewall, with third-party vendors also. So if I'll just show you Cisco pxGrid partners, let's see that the partners, what are the technical alliance partners are there. You can see that Apple, Absolute Soft, Amazon Web Service, Box, Checkpoint, Dell, Citrix, Demisto, DF Labs, Elastica, so many, Google, Infoblox, Limita, McAfee, Microsoft, NetScout, Mobile Iron. These all other companies by which the Cisco has already done what? Cisco has already done the collaboration. Symantec, Splunk, Sophos, so many different companies. So pxGrid is basically a platform exchange. What is pxGrid basically? If I'll just click it over here, Cisco Platform Exchange Grid, where from one identity, one kind of a device, one kind of a platform, all these devices, whatever I said right now, all are next generation devices. Next generation devices have the capability to build the contextual information. I believe everyone understood now what is a contextual information. Who is connected, what is connected, when is connected, where it is connected. All, not only ICE can do, your Palo Alto can do, Checkpoint can do, Symantec devices can do, your AVG antivirus can do, right? Your next generation firewall can do. So when you change that contextual informations built by one device to the another device so that he can take certain actions on the basis of that, that integration is called as what? pxGrid integration. That ICE pxGrid controller, that is basically a license. You need to buy a license for the same. Okay, so let's read this definition one more time. Cisco ISE is a centralized security solution that automatically builds or makes a context-aware access to the network resources, and with the help of pxGrid licenses, share that contextual data and can receive that contextual data also from any XYZ devices. ISE can come in a physical format. ISE can come into the virtual format also. ICE is basically nothing but a network door present in the beginning of all the initial devices, and those devices, they always look for what the ICE so that they can get what? Authenticated or AAA. ICE is nothing but a AAA server. ICE can do a profiling, ICE can do a posturing that I'll explain in a few minutes. But ICE can also tell and build a contextual data like who are you, what application you are using to connect into the network, when you connected, where you connected with Wi-Fi, you connected with the wired or through the VPN, and what is the device compliance for that. All this data, ICE has the capability to give the access to those particular end devices in the network, that is access policy. ICE can do the role-based access also. ICE can do what the guest access, ICE can do bring your own device access also. This is an overview about the ICE. Is this slide clear to everyone? Now let's talk about what is profiling. So in the industry, there was a challenge. What was the challenge? Device identification. Plenty of different devices types such as printers with different companies, IP cameras again with different vendors, mobile phone, Apple, Samsung, Lenovo, Motorola, HP, notebooks, different companies, requires huge amount of time and the administrative effort needed for the proper device classification for further controller access based on different access group access control policy for different device groups. So what is happening basically is ICE gives you a solution for that. What solution he gives? Cisco ICE profiling. Profiling dramatically decreases the time and the effort required for proper devices classification. What do you mean by profiling? Device classification. Understand like this. Profiling, you are doing profiling of this device. You are classifying that device. You are doing a device classification. Okay. So profiling dramatically decreases the time and efforts required for the proper devices classification. This automated process automatically happens, examines the network traffic and analyze it for specific characteristics, that identity, device type and operating system, such as Windows laptop or Cisco IP phone, or it's a Google device, it's an Android, it's a smartphone, it's an Apple OS, and so on and so forth. So what ICE does basically is, ICE has a capability. ICE has a capability whenever an end user connects through a switch towards an ICE. It is not necessary the end user is going to connect through switch only. End user can connect with a SSID also, with an access point also, which is getting connected with an ICE. Okay, this is called as wireless, or this is called as wired network. What I'm trying to say here is basically, no matter it is connected with wired or wireless, the moment he gets connected, ICE is going to get certain details for that. Who is that? When it is connected? What application it is using? Where it is connected? And how it is connected. These all are the things that ICE will identify. Most of the things will automatically be known by the ICE, but to do the profiling, or also called as device classification, ICE is going to use, we'll see that later into section, will take help of certain probes. Probes, remember that. ICE will use certain probes. Probes are nothing but protocols. And those protocols will fetch the information about the end users. And the probes like radius protocol, it could be HTTP, it could be Nmap, it could be SMTP, it could be DNS, it could be DHCP. These are the protocol which gets connected, which takes the information of these devices, and they can tell about which operating system the end user, accordingly it will put into a folder. Let's say for example, this is Windows laptop, Windows 7 laptop. which, because every end user will have a MAC address, right? Every end user will have a MAC address. MAC address is basically of 48 bits. That 48 bits is being divided into two portions, 24-bit as well as 24-bit. So one is called as organization unit identifier or vendor ID, like that. So by looking to the MAC address, first 3 octets, the last 3 octets, we'll come to know that, okay, this is Dell. So in the ICE already so many folders are already created. Dell, you have Apple, you have HP, you have Lenovo. So how this device automatically, how ICE is going to automatically put, the moment this device connects, this device automatically goes into the Dell, and that to enter the Dell Windows 7 option, automated process. This is called as device classification, device identification. You don't have to check in, let's say for example, if in your company you have 50,000 users are there, how many users you're going to check individually by looking to their MAC address? Okay, this gentleman is using Windows, this gentleman is using Apple. There should be an automation to that process, and Cisco ICE uses certain protocols which we call as probes to do this automation. So let's read this challenge and what is the solution that the Cisco ICE gives. Plenty of different device types such as printers, IP camera, mobile phone, notebook, tablets required huge amount of time and administrative efforts needed for the proper device classification for further control access based on the different access control policies for different device groups. You can say that Dell boxes should not be allowed. You can say in that way HP boxes should be allowed in that. So for the entire, you don't have to individual do that. You can make a group policy also, like all the HP users, no matter whatever the operating system they are using, Windows 7, Windows 10, Windows 8, Windows Server if they are using, HP devices, any HP devices. HP devices consist your printers also. HP devices consist your mobile phone also. Any in my network, anyone who's coming with the HP devices should be able to get into the VLAN number 10. That is how the granularity increases in the world of the ICE. So Cisco ICE provides you a feature that is called as a profiling. Profiling dramatically decreases time and efforts required for proper device classification. This automated process examines the network traffic and analyzes it for specific characteristics that identify what is the type of device by the protocols which I'm trying to say, probes. What is the operating system? Among them, Nmap is the one which always decide what is an operating system. It scans the operating system, such as Windows, Cisco IP phone, Google Android, smartphones, or Apple iOS devices over here. This is called as profiling in Cisco's ICE. Device compliance. That means what I'm end host compliance, many other names are there. Let's say for example you want to add a condition in the sense, I have Mr. Bob over here connected to the switch, connected to the ICE, router, firewall, ISP, and then internet. What I'm trying to say that this Bob gets connected to the ICE, goes here in its database. ICE is going to check authentication done. Authorization needs to be, like, he gets VLAN number 10. But before giving him the authorization, we can add one more layer of security to that. What is the layer of the security that I can add it over here? Simple, let's understand in this way. I can say that Bob can access internet only when he should be authenticated, if and only if he is using an antivirus of AVG with the updated version. Like, I can keep on adding the things. His Mozilla Firefox should be updated with the version 69. He should be using Windows 10. And this Windows 10 should be updated and licensed version. Like this, you can keep on adding antiviruses, what software you are using, all the software like Kaspersky, you are using internet antivirus, that XYZ thing. That means device compliance. This is called as device compliance. That means you are adding a posture. You are adding a posturing. This is also called as posturing. What is posturing? Let's read this out if I have it. Yes. In most cases, it's not enough to perform just authentication of the end user. Compliance check of the end devices such as computer, laptops, or smartphones can be even more important than just authentication of the user sitting behind the device. Cisco ISE gives you a solution which is called as posture service. Posture service allows you to check the state of the device, state of the switch, state of the end user. What is the state? Which Windows he is using, whether that Windows is updated or not, which antivirus it is using, whether that antivirus is updated or not, whether the browsers are updated or not. So that is called as state. So also known as posture of all the endpoints that are connecting to a network for the compliance with the corporate security policies. Mobile device management services can perform check of the mobile devices using the third-party MDM solution, which is Mobile Iron. This allows you to control the clients to access protected area of the network. That means you are not only doing the profiling, which is an automated process, right? It's an automated process. It is going to do what? It is going to check, and immediately it will put into that particular folder according to the MAC addresses. Automation has been done, profiling can be done, and along with that, Cisco ISE provide you the posturing also. So in our day-to-day life, it is not, it is like you have a MAC address, you are taking a laptop 2007 with Windows 2007, old model, your Microsoft Office itself is 2007, you are using an antivirus 2007 in the year 2020, you got authenticated, but all these are vulnerable like anything, because you are running in 2020, 13 years before. The signatures or the malwares, this laptop is going to get infected in within 5 seconds in the production, the moment it gets connected to the internet. So the device authentication is not the end result. Compliance check is also an important. ICE check the state of the end devices. ICE does the posturing. Does this make sense to everyone, this statement also? Now we're going to talk about certain ICE terminologies. Okay. Certain ICE terminologies we're going to talk about. Like, first terminology, node. What is a node in the world of an ICE? An individual, physical, or virtual Cisco ICE appliance. You bought an ICE, could be physical or could be a virtual. That device is called as node. Then we have an option called as node type. The Cisco ICE node can assume any of the following personas also, like what are the type of the nodes? Administration, policy service, or monitoring. Then we have personas. What is persona? Determine the services provided by the node. A Cisco ICE node can assume any of the all the following personas. The menu options that are available through the administrative user interface depend on the role and the personas. Services. A specific feature that a persona provides, such as network access, profiling, posturing, security group access, monitoring, and troubleshooting. Role. Determines if a node is a standalone, primary or secondary node, and it applies only to the administration and monitoring nodes. Let me explain you now in my way. When you buy an ICE, ICE has certain personalities, like what ICE can do. ICE gives you administrative functions. ICE helps you to do monitoring and helps you to do the troubleshooting also. And ICE provides you the services also, that AAA services. On the basis of these particular things, ICE makes its own personality. That is called as personas. There are 4 types of personas we have: PAN, MNT, PSN, and pxGrid. The 4th personality comes with an expensive license. And you know what is pxGrid? That means integration with what? The third-party devices over there. PAN stands for Policy Administrative Node. MNT means monitoring and troubleshooting. PSN means Policy Service Node. PSN stands for Policy Service Node. By default, when you buy a ICE, it could be a virtual machine or it could be a physical. If you have only one single ICE, one single box, this is called a standalone node, a standalone mode. Only one device is there. So this ICE is going to provide all the 3 personas, because by default is there PSN, PAN, and MNT. Okay, this is going to provide all the 3 personas will be. If you want the 4th one, you require a license for that. I can deploy in a dual mode also. Dual mode. That means I have 2 ICE. ICE 1, ICE number 2. Okay. ICE 1 is going to provide, we can split it out like this. PAN, his role is primary. PAN over here is secondary. You got my point? Like active failover, if you remember. Monitoring, secondary here. Monitoring, primary here. And PSN, active here. PSN, active over here. So can I write one conclusion regarding the role? Your PAN can be maximum 2 in the production, and they go with active standby mode. Primary, secondary means active standby. Your MNT in the production can be maximum 2. That means when I'm saying maximum 2 means if you have 10 ICE in your production, 10 ICE. So among those 10, 2 can be maximum, can give a role of MNT. 2 can be maximum give the role of PAN. Remaining all 8 can provide you PSN. And PSN can have maximum 50 nodes in the production. 50 nodes, 50 PSNs you can have maximum in a particular company. So what I'm trying to say, this is called as 2-node deployment. So this is basically role. What is the role? So role could be active, standby. Personality is, this is persona. This is persona. Okay. Single server, VM or physical, that is called as node. This is node, ICE node. ICE 1 is a node. ICE 1 node gives this personas, and in that persona, PAN role is primary. PAN role is primary. In ICE 2, MNT role is primary. PSN, policy service node, which provide, what is PSN? What is PAN? What is MNT? Let me explain that also. PAN is nothing but from where you can do all administrative work. PAN is a place where you're going to do all administrative functions, like you're going to create role-based policies, authentication policy, authorization policy, RBACs, everything will be adding the database, external database like Active Directory to be stored. Everything will be done from PAN. Administrative work, rollback, backup, integration, patching, and upgradation, everything will be done from PAN. What is MNT? Monitoring and troubleshooting. This is a place where you're gonna check all the reports and do the troubleshooting, live logs, radius logs, TACAX logs, all the logs. And there are certain troubleshooting tools are there which can tell you and help you in that. What are the commands that you are missing on the particular devices? This will help us to do monitoring, reports, and troubleshooting. By checking the reports and the outputs of the logs, you can analyze that. What could be the issue? PSN is that device. From the PAN, you're gonna do the configuration, authenticate Bob and give him the authorization VLAN 10 and access list permit IP any. So when the Bob comes into the picture, it gets connected to the switch, it will get to this PSN, and this PSN is going to get authenticate Bob, not that PAN device. PAN is just a device where you're gonna do what? Simple configuration. Now, to more get a clarity, let me draw a simple diagram like 4-node deployment. 4-node deployment. What is 4? First, I'll draw all the nodes of deployment which is possible. One is called as standalone node. Stand-alone node. What is node? Single server, single ICE, whose name is ice.cisco.com and his IP is 150.1.7.1. Let's assume like that. This node is going to give me PAN because it's a standalone, will provide me PSN, will provide me MNT. That means Bob is going to get authenticated by 150.1.7.1. This is the IP. If he is not getting authenticated, I want to do so. The PSN will be provided, policy service node, which node is going to take the decision whether Bob is going to get authenticated or not. 150.1.7.1. Whether he got authenticated or not, he is going to generate the logs, and logs will be seen by 150.1.7.1. That means MNT will be done by the same device is going to provide you the monitoring and troubleshooting logs. Same device is the device 150.1.7.1 where you're gonna do the configuration for the Bob. That means PAN. You're gonna do the authentication. That is called as basically the services. Services are what? Personas are what? 3 types of personas: administration, PSN, monitoring. What are the services? Administrative will give you the upgradation, authentication policy, authorization policy, NTP, LDAP, upgradation, patching, backup, restore, scheduler, all are administrative things. What is policy services node? Policy. So that PAN persona is giving the services. That is called as services. What? Every persona has a services. Every persona gives certain services. PSN gives services. Policy services node. What are the services? He is going to authenticate, authorize, and blah blah things. MNT is going to provide its own services. Role. What is role? Role comes into the picture when you have more than one ICE. Now I have 2 ICE. Let's say, for example, ICE number 1, and I have now ICE number 2. Domain name ice1.cisco.com, ice2.cisco.com. His IP is 150.1.7.1. His IP is 150.1.7.2. Now what we do is, when you have 2 nodes, PAN will be primary here and PAN will be secondary over here. Role got changed now because 2 devices. When single is there, there is no funda of role. All are active. MNT is secondary here. MNT is primary here. There is no concept of primary and secondary for PSN. It is active here. It is also active over here. So if I want to do the configuration to authenticate Bob, we need to do configuration that will be done from 150.1.7.1 because this is PAN and he is primary. Whether Bob is authenticated or not, to check the logs, I will write an IP 150.1.7.2 because this is MNT primary. Which device will take the decision? In between, you can have a load balancer, FI load balancer. That request can go to ICE1 or ICE2 because both are active, both are serving the same PSN. So which device will take action? It could be ICE1 or it could be ICE2, depending on the load balancer that you are using. This is dual node deployment. Similarly, you can have 4-node deployment in which you have 4 ICE. This is PAN primary, this is MNT primary, separate 2 boxes for PSNs. And like this, you can have up to 50 PSN in your network, but only two PAN and MNTs. So PAN can be maximum 2. The role of the PAN is primary or secondary. The services of the PAN are like authentication policy creation, authorization policy creation, backup, users creation, database creation, so and so forth. MNT can be maximum 2. Role, primary, secondary, services, logs, live logs of radius, troubleshooting tools or diagnostic tools available over here, services. PSN, no role at all. All units are active. All 50 units are active. More than 2 devices, use load balancer in transit. I hope this is clear to everyone, guys. So this is ICE communication model. So this tells you multiple things over here. Let's see that. So there is a client. Oops, there is a client over here. Okay. This particular client is going to do what? Going to initiate the traffic, as you know. And once he's adding the or sending the traffic, it will always get connected to the NAD. NAD stands for network attached device. Client can never get connected with the ICE. Understand? You have Bob user. Bob cannot directly connect with the ICE. In transit, you have certain devices. That device can be a switch. That device could be an ASA firewall. That device can be an access controller, access point, or WLC controller. That could be a router. That could be any device. That device is called as NAT. So the moment the client sends the traffic, I'll explain what is access request. It will go towards the PSN, policy service node, who is going to take the decision whether I'm going to authenticate it or not. If the PSN has all the policies related to this Bob user, if he is going to authenticate it, he is going to tell Bob, you got authenticated, and Bob can access the resources. In return, he is going to send the logs to the MNT. Who is MNT? Which is going to take the logs over there, right? Policy service node is going to check the administrative and any in between, whenever he's checking any policies, any new addition has been done on. So the synchronization is continuously being done. I gonna configure the things from admin. It is going to push into the PSN. It is going to push into what? The PSN. The traffic comes to the PSN, whether he has taken the traffic or not. He will send the logs to the MNT. To view the logs and the reports it from the admin, you can go to the monitoring, or you can directly open the monitoring and see the logs over there. This is how this ICE does the communication. Have a look. Client reach to the switch, a NAD, PSN. Now this can do a external authentication also. It can go for the external Active Directory or LDAP servers or any other TechAct servers over there. It can reach out over there. No problem in that. If the external identity source says that yes, I have the data for that particular bot, it is going to authenticate. Client is going to access the resources available over there. But in between, the moment the PSN has allowed him, he will send the report to the MNT also. And from MNT, you can check whether he got authenticated or not. Everything will be there in that particular segment. So this is called as ICE communication. The question is, between the nodes, is there any special link? Like you have cluster control link. Remember in clustering or an active standby, you have failover links are there. No, there is nothing like that. You can have, sir, one ICE in Dubai. You can have ICE 1 in Dubai, which is your PAN primary. You can have ICE number 2, which is MNT primary. It could be in Bangalore, and your 2 PSN can be there in different geolocation. All could be there in a different geolocations. All could be just normal reachability. You got my point, Riyaz sir? It's a very good question. Just normal reachability will do the synchronization between all the devices. There is no special link which is being required. There is no special link which is being required. Look what we have done as if now. I believe what is identity, everyone is cleared. What is an identity store, everyone is cleared. I've given you an overview of the ICE on day 1. This is day 1 which we are doing. Hardware and software information I've told. What are the hardware devices? What are the, and the software information is basically 2.4, which version we are talking about. I believe everyone now knows about the profiling. Everyone knows about the posturing also. ICE terminologies, node, services, personas. ICE personas node, deployment and implementation. That is nothing but how to deploy single node deployment, dual node deployment, and you have 4 node deployment. All the things are there. ICE communication model also I've explained it. So these are the things. This is day 1. This is day 1 of ICE, which we have done. Okay, let me just go over here. This is day 1. What we are doing, day 1 of ICE, we have done till ICE communication model. We'll start from here. Day 2 ICE, we'll see in the next lecture.